Hello, and welcome to Most Significant Bit, a podcast that explores the connections between engineering, technology, humanities, and the arts. I'm Luke, and in this episode, we'll be discussing honeycomb structures, what makes them special, where they're used, how they're made, and their impact on society. The first question is obviously, what is a honeycomb structure? Well, put as simply as possible, it's a structure that resembles a honeycomb. So think hexagons that are hollow inside, repeating in a lattice pattern. Because it's got this lattice pattern, it can just be continued for as long as necessary, allowing for some fairly unique properties. For example, honeycomb structures are known for being strong in compression and shear, yet they have the ability to be compressible when they're pushed against on their sides, or kind of the sides of the hexagons. Um, in addition to that, it's a lot more rigid when it comes to pressing against the faces of the hexagons. Being that they're mostly hollow inside, it's a lot of just open space in these structures, which leads to them being a lot more material efficient, lightweight, and because they're more material efficient and lightweight, they tend to be cheaper than if you were to just use typical, maybe bar steel or sheet metal, which leads to them being the ideal solution for a lot of different industries. Specific examples would be automotive, aerospace, and sports, where their lightweight and efficient configurations are most useful. An automotive example includes the Jaguar XJ220, which was a supercar built in the 90s that featured a chassis including the honeycomb structure. So it had frame rails with this structure inside them that was providing superior rigidity while also passing the standards for impact testing. Another significant landmark for honeycomb structures includes the Boeing 747, which was one of the first ever aircraft to go into production using it. Its wings and its cabin floor included this structure, which reduced its weight and once again its rigidity and slight compression properties was very useful. To round out the three industries mentioned, I'm going to bring up the football helmet. It's a perfect example of this because I'm sure you know by now the honeycomb structure is lightweight, it's rigid, and it compresses a little bit under certain conditions, which is exactly what you want in a football helmet. That sort of harder exoskeleton protects smaller hits, and then when you get hit just right, the helmet will compress enough to protect the players' heads and even save lives. Now, the next question you may be asking is, how is a honeycomb structure made? Well, we don't have bees make it, we actually make it ourselves. So, similar to bees, way back in 60 BC, we were forming these structures by using lost wax casting, where it would be a wax mold, and then you would heat something up and pour it into this mold to let it dry, and then remove the wax to have your structure. And then we moved on in a long time later in 1877 to using a paper paste and glue mixture, a bit like paper mache, to harden, stiffen up this structure, but you kind of make it by hand and then place it on or in whatever you're using it for. Then later in 1890, we, with the invention of corrugated metal a couple of years before, were able to then take sheet metal and form it into these shapes. And these shapes could be, I'm sure you guessed, honeycomb structures, which was very beneficial to just being able to produce a lot of it cheaply. And then after that, in 1934, we were able to start welding. That's when welders were kind of coming around. So we could take, this corrugated metal and then we could make it uh, stronger. We could weld it together. And so we were able to create honeycomb structures in different directions than we previously were able to. Now, in the modern era, we're able to use not only metals, but also special composites that we've been designing. And of course, we've got 3D printers and all sorts of CNC machining that we can make custom pieces with, and that definitely includes lattice structures like honeycombs. But we also have way more efficient ways of mass producing it too. The main one being extrusion, like you'd use 80/20 extruded aluminum, for example. This is the exact same process. Another great example of this is stamping. So whenever you have more of a sheet of this honeycomb, you can just load it into a machine and it will go through and just stamp out the holes, and out the other side comes your honeycomb sheet metal structure. Now, the final question is, how does this impact society? Well, we already know it's used in pretty much everything, as well as it's better for the environment. It uses less waste, and it's just generally more efficient. And then we're also able to do things like create artificial beehives and come full circle to help the reducing bee population. And then finally, you see it in places like art or just like sound deadening panels on walls. It's used as decoration too. Today we covered the basics and more of honeycomb structures. Honeycomb structures are lighter, cheaper, stronger, and more space efficient than many counterparts, leading to their success and widespread use in the world. This has been Most Significant Bit, and I have been your host for today. Thank you for listening, and be sure to watch out for examples of honeycomb structures in your daily life.